Hi friends, today we are going to discuss the first topic in the third unit of discrete mathematics, combinatorics. So this combinatorics is the branch of mathematics concerned with the problems of counting. These techniques of counting are very important in mathematics and computer science, especially in the analysis of algorithm, that connectivity of networks, so on, etc. In this chapter, we are going to discuss what is the basic concepts of counting and their applications. Counting and their applications, right? So first we will go for the elementary combinatories. What are the fundamental principles we used to counting, right? So two rules are there. One is sum rule and another one is product rule. So depends upon. So if any problem which contains or, then we use the sum rule. If it contains and operator, then we use the product rule. Sum rule. How to apply the sum rule? If an event can occurs in m ways, if any event can occurs in m ways and another event can occurs in n ways, if if these two events cannot occur simultaneously, then one of the two events can occur in m plus n ways. So these are uh, cannot occur simultaneously, then one of the event can occurs in m plus n ways. Then we use sum rule. So coming to the product rule, if an event can occur in m ways and a second event can occurs in n ways, and if number of ways of the second event occurs does not depends upon the occurrence of the first event, then the two events can occur simultaneously in m into n ways. Simultaneously m into n ways means the second event, if it is does not depends upon the first event, if it does not depends upon the first event, then m into n ways means we can apply the product rule. So let's suppose go for the example problems. If there are 14 boys and 12 girls in a class, if there are 14 boys and 12 girls in a class, find the number of ways of selecting one student as a class representative. So one student of the as a class representative from 14 boys and 12 girls means it may be either boy or girls, either boy or girls. So first selection of one student from the following boys: 14 boys and 12 girls. So selection of one boy from 14, or selecting one girl from 12. Selecting one boy from the 14 or selecting one girl from 12. So first of these can be performed in 14 ways. First one, selecting one boy, maybe 14 ways, and the second one, selecting one girl from 12, means 12 ways. Therefore, by the sum rule, either of the two tasks can be performed in 14 plus 12, 26 ways. There are total 26 ways to select one class representative from 14 boys and 12 girls. So here main r is coming, so that's why I am using sum rule, right? Next, if three persons enter into a car, whether there are five seats, in how many ways can they take up their seats? So total number of seats are 5 in a car. So if a first person has a choice of 5 seats, if a first person has a choice of 5 seats, and he can sit in 5 ways. If the second person, how many choices are there? Only there are 4 seats are there, so there is only 4 ways. Similarly, the third person, only the choice is only 3 seats, so 3 ways. So hence the required number of ways in which the which all the persons can take up the seats is 5 into 4 into 3. So there are 60 ways they can take up their seats. Similarly, how many how many 3 digits number can be performed using the digits? So total number of digits, how many digits are there? 1, 2, 3, 4, 5, 6, 7. So there are total 7 digits are there. So without repetition, if no repetition is allowed, so how many 3 digits numbers can be performed? So 3 digit number means it contains 100 place, 10th place and 1's place. So 100 place. First, if I go for the 100 place, So how many ways are there? So total 7 numbers of any of the one number can be adjusted here. Let's suppose 2. First is 2, if 2 is fixed. So remaining 2. So how many 107 numbers are? 7 ways are there. So 7 ways are there. So 100 place can be filled by any one of the given 7 digits. So 7 ways. There are 7 ways are there. So how many remaining? Only 6. 100 place is gone. So remaining is only 6 digits are there. So 10th place, how many ways? 10th place, 6 ways. So 100th place gone, 10th place is gone, means 2 digits are over. So remaining 5 digits are there. So ones place only 5 ways. Once unit place can be filled by 5 ways only. So by the product rule, so one does not depends upon the other, one does not depends upon the other, right? So if by the product rule, the total 3 digit numbers is 6 into, sorry, I mean 7 into 6 into 5, to 210 ways are there. We can form a 3 digit numbers, we can form 3 digit numbers, right? So already in the intermediate level, you know what is combinations and what is permutations. But even though, just recollecting the basic concepts of the combination. A combination is a selection of some given elements in which order does not matter. Combination is selection of some given elements in which the order does not matter. Order does not matter. The number of all combination of n things taken or at a time is NCR, where NCR is nothing but n factorial divided by n minus r factorial into r factorial. So NC0. So n factorial divided by n minus 0. N factorial into 0 factorial is 1. N factorial gets cancelled 1. NCN. So n factorial divided by n minus n. 0 factorial is 1. N factorial divided by n factorial is 1. Similarly, NCR is equals to NCN minus R. So if you evaluate, we will get the same value, right? Find the number of subsets of the set 1, 2, 3, 4, 5, 6 having three elements, right? So I need the subsets of these sets. Each subset contains at least three elements. Each subset is containing having only three elements, right? So what is the cordiality? Cordiality means number of elements in a set is nothing but cordiality. So 6 elements are there. So and we have to choose only three. We have to choose only three. So the answer is 6C3. 6C3. So 6C3 is the answer. Why? Because there are the number of subsets will be 6C3. So to evaluate 6C3, 6 factorial divided by 6 minus 3 factorial into 3 factorial means 6 factorial divided by 3 factorial into 3 factorial. Just evaluate, we'll get it as 20, right? Next, if there are 6 men and 5 women in a room, in how many ways we can choose 3 men and 2 women from the room? How many ways we can choose 3 men and 2 women from the room? So the number of ways to choose 3 men from the 6 men is 6C3. Similarly, 2 women from the 5 women is 5C2. So 6C3, 5C2. There does not depends upon each other. So then we have to apply the product rule. What is the product rule? 6C3 into 5C2. 6C3 into 5C2. Just evaluate the value of that one. We'll get 200. Right? Similarly, just already you know all the problems in combinations, as well as the next topic is permutations. So you know, but just we are recollecting. How many ways can we choose? 3. How many ways? Sorry. How many ways can you choose 3 and 3 students for first group and the, so let us the number of groups as 1, 2 and 3, right? For choosing 3 students for first group, the number of ways are 9C3. The number of ways of for choosing 3 students for second group after choosing first group is 6C3. Right? The number of ways for choosing 3 students for third group after choosing first and second group is 6C3. It's the total number of ways is just multiplying One, why? Because one does not depends upon 9c3 into 6c3 into 633. Just evaluate the value of this one. I'm sorry, this is 3c3, 3c3. The answer is 1680. Right? Hope you understand all these things. Thank you.